This example is from MGF 1107, section 14.3, when you're asked to find a Hamilton circuit in a graph and to use the brute force method to find the optimal solution, which may be the minimum cost or the minimum distance, as it is in this example. So in this problem, we have a family, and they are going on vacation, and they had their kids pick different spots within 500 miles of their home, and then they're going to go on a trip to all of these different places. So by reading this, let's underline some important information. Their home is in Chicago, and one of their kids wants to go to St. Louis to go in the Gateway Arch. Another son, they have 3 sons, another son wants to visit Green Bay up in Wisconsin, and their third son wants to go to Ottawa, which is in Illinois, to see his grandparents. That's very nice. And then they give you information about the distances between all of those 4 cities. But the key thing, there are 4 cities: Chicago, St. Louis, Ottawa, and Green Bay. And we have 3 parts of this problem. The first part is represent this traveling salesman problem. It's called a traveling salesman problem because we want to travel to all these different locations and return back where we started without going to any of those locations more than one time. So we want to construct a completed weighted graph representing the problems that we have here. Now we have 4 cities. Each city is going to be represented by a vertex. So we're going to have a vertex for Chicago, a vertex for St. Louis, Green Bay, and Ottawa. And we can go from any city to any other city, but it's going to cost us. And it's going to cost us, in this case, in miles, and then obviously miles translates to dollars if you're driving. So to construct this graph, we're going to start with 4 vertices and then connect them all to make a complete graph. A complete graph, that just means there is an edge from every vertex to every other vertex in the graph. And then it has to be weighted. Now our weights in this problem will be miles. So each edge will have a weight to it. Now when we construct the graph, it doesn't have to be geographically accurate. You know, Green Bay does not have to be north of Chicago, and St. Louis does not have to be south of St. Louis doesn't need to be south of Chicago and such. We just have to have 4 vertices and connect them. And the ones that are further apart geographically do not necessarily need to be further apart in the graph. A short edge could have a longer distance to it. So I've already constructed the graph. So let me see if I can uncover that. Ta-da! There is a complete graph. It's not weighted yet because I have not assigned the miles to each edge. But you notice I have 4 vertices: Green Bay, Chicago, St. Louis, Ottawa, and an edge connecting every 2 vertices. Now to make it a weighted graph, we have to go through and add the weights to it. So it says Chicago to St. Louis is 300 miles. Chicago to St. Louis, that's 300 miles, that edge. Chicago to Green Bay is 205 miles. Chicago to Ottawa, that edge has a weight or a cost of 80. St. Louis to Green Bay is 500. St. Louis to Ottawa, 245 miles. And Green Bay to Ottawa, that edge is 280 miles. So recall, this family lives in Chicago. So this is their home base. They want to make all three sons happy, so they're going to visit all those other cities and then return back home, which means we have to form a Hamilton circuit because we want to visit each vertex exactly one time, and it's a circuit because we want to make sure we get back to Chicago at the end, which is where we started. Now, so step A, or part A, is accomplished. We have a complete weighted graph showing the distances on the appropriate edges. Part B, it says use the brute force method. The brute force method will find an optimal solution, or a min cost, or a min mileage solution. It just takes a little bit of work to do. So this method is probably the one that involves the most time and effort on this next test and quiz. Because to do the brute force method, we have to come up with all the different Hamilton circuits from Chicago, visiting all three other cities and coming back to Chicago. So I'm going to use the first letter of each town's name, and I'm going to write down the Hamilton circuits. Now there is a formula to figure out how many Hamilton circuits there are in a complete graph, and that is if you take n, which is the number of vertices, take away 1 from that, and then factorial, that will give you the number of Hamilton circuits. So we have 4 vertices, minus 1 is 3, but then that factorial will be 3, 2, 1. 3 times 2 times 1, which is 6. So let's list the Hamilton circuits. Let's start with, we always have to start with Chicago, then to Green Bay, then Ottawa, and St. Louis, and then back to Chicago because it has to be a circuit. Another one could be Chicago. Let's go to Green Bay. Let's go to Green Bay up here. But then let's go, instead of Ottawa, let's go to St. Louis, then Ottawa, then back to Chicago. Now let's go to St. Louis next. So let's start at Chicago, then go to St. Louis first, Ottawa, Green Bay, Chicago. You notice that's just the reverse of the top one. So they're going to go on the same edges, so they will have the same distance, the first one and the third one. Start at Chicago, let's go to St. Louis, but instead of going to Ottawa next, let's go to Green Bay next, and then Ottawa, and then back to Chicago. And then the last two, because remember there'll be 6 altogether. Let's start in Chicago. Let's go to Ottawa first, and then Green Bay, St. Louis, Chicago. And the last one would be go to Chicago, start in Chicago, go Ottawa next, and then St. Louis, Green Bay, and Chicago. So to do the brute force method, we do need to list all the different Hamilton circuits. Now again, it's unrealistic for me to have you do this if there were 5 vertices, because if you use the formula 5 minus 1 is 4, 4 factorial will be 24 different circuits. I would not expect you to do that. I would expect you to do this though if there are 4 vertices. Now what we have to do is we have to determine the cost in miles of each one of these Hamilton circuits. So to do that, we're just going to follow along. So let's follow this first path. Starts in Chicago, goes to Green Bay, then goes to Ottawa, then goes to St. Louis, and then back to Chicago. So that is a Hamilton circuit. We visited all the vertices exactly one time. Now let's find the cost of that Hamilton circuit by adding up the weights that are on all those edges. So it'd be 205 plus 280, I believe that's 485, plus 245 plus 300. So let's scribble that down real quick, or use your calculator. So if you did take your calculator and add up 205 miles plus 280 plus 245 and 300, you get 1,030 miles. And that would be the same one as going in the reverse order, going from Chicago to St. Louis to Ottawa to Green Bay to Chicago. So if you look at them very carefully, that would be the third one listed. So the third Hamilton circuit down would also have a total miles of 1,030 1,030. We need to do the same thing for each of the 4 other Hamilton circuits by tracing them on the graph and then adding up the weights of their edges to see what the cost or the distance of those Hamilton circuits would be. After calculating the total distance for all the Hamilton circuits, we can see that there are several routes that this family could take that would have the exact same total distance of 1,030 miles. There are 2 Hamilton circuits they could take to visit all those cities and return home that would be 1,160 miles. So part C of this problem said, what is the minimum distance the Pierces can travel? Well, if you look at the column that has all the different mileages on there, the lowest or the minimum distance would be 1,030 miles. Now, if it asked you which route or which Hamilton circuit they could take to achieve that minimum distance, any one of the 4 Hamilton circuits that have a total weight of 1,030 miles would be a correct answer.